Models learn by measuring mistakes. A cost function is a mathematical penalty score showing how wrong the model is. Today, we explore mean squared error and cross-entropy. Consider a house price model. It predicts $300,000 but the actual price is $400,000, a $100,000 error. For another house, it predicts $250,000 but the actual is $280,000, a $30,000 error. Without aggregating these errors into one single penalty number, how can the model know it's wrong? Cost functions solve this by summing and averaging errors into one score. The most common cost function for regression is mean squared error, or MSE. Here's how it works: take each prediction error, square it, then average all squared errors. Why square? It exponentially penalizes large mistakes. A $100 error becomes $10,000 penalty. A $10 error becomes $100 penalty. Squaring ensures big mistakes are very costly. MSE works best for regression tasks, predicting continuous values like house prices or temperatures. Cross-entropy is perfect for classification, assigning items to discrete categories like spam versus not spam, or cat versus dog. Both measure error, but for fundamentally different problem types. Choosing the right loss function for your task is critical to model success. For classification tasks, we use cross-entropy loss. Instead of predicting exact numerical values, the model outputs probability scores for each class. If the true class gets probability 0.9, excellent, low loss. If the true class only gets probability 0.1, terrible, high loss. Cross-entropy heavily penalizes wrong predictions, especially when the model confidently assigns probability to the wrong class. This forces the model to be both accurate and confident. The cost function doesn't just measure error, it actively guides learning. During training, the model calculates the gradient of the cost function with respect to its parameters. This gradient is a vector pointing downhill toward lower loss. By following this gradient step by step, the model progressively reduces its penalty score. This feedback loop, calculate cost, compute gradient, update weights, repeat, is the core mechanism of how neural networks learn and continuously. As the model trains, the cost function measures error at each step. Watch the loss curve. It descends, showing improvement. This is the power of cost functions, providing clear signals that guide models toward better. Cost functions measure model error and guide learning. MSE for regression, cross-entropy for classification, both convert raw errors into actionable signals. That's how AI learns to be less